Hello, I am Harsh Khattar, working as Assistant Professor in Department of Computer Science and Engineering at ABES Engineering College, Ghaziabad. Today, I am focusing on the serial communication in computer architecture. Till now, we have discussed about the interfaces, interrupts, and how the devices are communicating with each other. So, let's have a look to the last topic, which is serial communication, how the devices are going to communicate with each other and by which mode. As we know, there are so many devices which are going to communicate with CPU for the execution purpose. So, generally we have a bus architecture where the device is sending its own signal to the CPU and CPU is receiving it. Therefore, the execution will be done easily. The vice versa is also possible, that the CPU is giving the instruction to the devices with the same bus. In this class, we will focus on this bus and how this communication is going to execute. We know that we have a separate processor for this, which is also known as input output processor. With the CPU, central processing unit, which is our main processor, we have another component which is IO processor, which is meant for all IO devices to communicate and manage the priority levels. If I have various peripherals, then all these peripherals are first sending the signal to IO processor, and here the interface with each device is there. We can say that we have a main component CPU, then we have IO processor for this, and then the devices are connected with each other with the help of bus. Now, what is the importance of serial communication? How IO processor is doing this? Already in the previous class, you have seen the IO processor and the main processor communication, how the CPU is giving instructions to the IO processor and how the IO processor is interrupting the CPU that yes, my work is done. So, this is a detailed description about this communication. So, let us have a look to this serial communication, how it is going to be happen and what are the protocols. Protocol means the rules for the communication, how the a treaty is done between the devices that you need to follow these rules, and these rules are known as protocols. So, we have some protocols under serial communication of the devices. What is the meaning of communication? Means how the devices are talking to each other. What is the serial communication? That various devices are in a line, they have lined up with their requests. So, the first request goes to a particular device 1, then device 2, then device 3, because we have the resources which work in both categories, serial as well as parallel, and then they have different modes like synchronous, asynchronous. So, interrupts, asynchronous and synchronous communication, this part is done. So, our focus is on the serial communication. As it is mentioned here that the communication among the devices is very important if we want a perfect execution. Say a command is going to execute by the CPU and device 1 is performing it as a output. At the same time, device 2 is interrupting, and due to this interrupt, my current execution is distorted. So, this is not a good thing, and we as an end user will not accept this thing. So, here a proper communication with the signals are required. So, that is why it is mentioned here that we have a IO processor which is designated for the perfect data communication, and this is a whole sole responsibility of IO processor. With this IO processor, what we have next, that we have a device set, for example, this modem. When we talk about the modem is one device which performs two operations. What are those operations? Let us have a look to the modem. As we know, the data which we are going to send to a particular device. This data, for example, I am saying something and you are unable to understand English. In this case, we need some interpreter which converts my English language, English words to your native language. So, in this case, this part is converted with the help of a device here or some software here. So, here some interpreter is required, some interface is required. So, we can't say the speed of my speaking is mapping 100% mapped with the understanding level of the student. So, both can be different, might be some of the students are grasping the things very fast and my speed is slow. Might be some of the students category is like this, which is treating that I am talking fast or I am covering the syllabus very fast, but they are not easily understand all the topics with my speed. So, here when we have a variation in the speed, we have a variation of format in understanding, means I am talking about a complete block and the end device is studying about the basic bits. So, here we have some variety among the two entities. So, in this case we need some interfaces and devices. So, very popular one is the modem. So, when we talk about the modem is one device which is especially designed for the communication purpose in the computer, which has the two things, modulation and demodulation, means the conversion of the signals in modulated form and then at the receiver end this is demodulated. So, it is comprises of modem. Modem basically converts the digital signal into the audio tones to the transmit purpose, and similarly it is going back to the digital form when it comes to the receiver end. So, in university exams sometimes it is asked, they ask about the what is modem and what is the role of modem in serial communication. So, the role of modem is to convert the signals so that the communication can be done easily. When we talk about the mode of transfer, for example, I am sending a signal. So, what are the mediums, what are the modes we have to communicate among the devices? So, these are of three categories. Category means I am right now giving this lecture and you are unable to give the response at this moment, means this is not a live class. So, in this case this is one way communication, means I am here to send the data and you are receiving it, that's it. Your responses are not coming to me. So, this is the first mode which is known as the simplex mode. Simplex means it is a one way communication, and the terminal A, suppose I am terminal A and you all users are terminal B. So, the data is going to you. So, this is a direction which is shown with the help of this arrow. So, this is simplex mode. Another mode is I am one device, you are one device, and at the same time only I can talk or you can talk, means both way communication is possible, but one at a moment, like walkie talkie. We have seen these examples in the movies that from one side they are saying, okay, hello, I am Charlie, yes, this is what I want to inform, yes, I am taking a lecture, over. After over, the another person is clicking on the button and saying, yes, I have received your message, over. So, over and out like this. So, at the same time we can say something, another one is perceiving it. At another moment the second person is talking and we are listening. At the same time both can't communicate. So, this is the another example of communication which is known as half duplex. Duplex means we can say the two entities are participating and receiving and sending the data, but it is in half mode, partial mode. At the same time both can't talk or both can't listen. So, this is the another example. The third case is one, we are talking on a mobile phone. So, at the same time both are listening and both are talking. So, mobile phone is the example. Okay. So, this is under the full duplex mode. So, you can see the difference in figures as well, that we have here terminal A and terminal B. These are like the devices, these are like the nodes, and they are communicating here. Transmission is either direction, but not simultaneously. Means we can send the data from A to B as well as B to A, but at the same time it is not possible. If at the same time it is possible, then this is converted to the part C, which is full duplex mode. So, these are the mode of transmission. Generally, there is a theoretical question on this, that write a short note on mode of transmissions, or what is the difference between simplex, half duplex and duplex. Now, the next is basically the protocols. As I said, there are some rules which are defined for the proper communication. Here our rules are of two types. One is basically known as the bit oriented and another one is character oriented. Character oriented is also known as byte oriented. Bit oriented is something where we are sending the data in a form of bit. When we are talking about the character oriented, we have a block of bit. Generally we say we have a byte, and byte is a collection of 4 bits. So, this is also known as a character oriented. We can also take a larger data block here to send the data. Means what is the significance of this topic here in computer architecture, in organization. So, this computer architecture and organization is basically talking about the communication among the devices. The CPU is communicating with the devices. So, here all the devices are not perceiving the data in form of bits, in form of bytes, in form of blocks. So, based on the nature of the devices, the data is coming to them and they are understanding the data. For example, if I am hitting some key, so the key stroke is converted to the ASCII value, and this ASCII value is coming to the CPU, which is in the form of bits, right? One ASCII value is of 7 bits. Similarly, when I am talking about the printer, a printer is perceiving the data in form of a block. You are not sending us one by one bit and computer is giving a command that in these one page we have 20 lines and you need to print character by character. No, that dot matrix printers are over now. Now it is a laser printer and we have a complete block of data, and that block of data is taken by the output device printer, and printer is printing it. So, here based on the nature we have the two protocols. One is the bit oriented, another one is character oriented. So, here if I talk about the description of this, so let us have a look to the bit oriented. Bit oriented protocol is one which allows the transmission of serial bit stream, that one by one a serial bit stream is going. Suppose my data is 101010. So, first the 1 is going here, then 2, this 0 1 0 1 0 1 like this. So, here this series of bits is going to transmit from one device to another device. Now, here one of the device can be a CPU or they are directly the peripheral devices. Here we have the examples, like we are known about the HDLC and SDLC, means this is a synchronous data link control, or we can say the high level data link control. These are the protocols which are generally used at the data transmission here. So, these are the protocols which are well defined, which says that the communication is done in a serial manner with these fixed parts. Another category is basically the character oriented. Character oriented, as I said, we also known this protocol by the name of byte oriented protocol, where we have a set of bits and we are transmitting it in the form of chunks. Like this data is directly going there, then again a set of 8 bits means 1 byte and we are transmitting it. So, this is directly moving in the form of block, and the execution, the meaning of the data is when we are collectively treating these blocks of data, blocks of bits together. So, this is the nature of a particular device if it is under the character oriented protocol. So, here as it is mentioned, we have these binary codes in the form of character set, but we have a complete set, means individual 1 bit can't say anything. When we have a 7 bit set, or we are collectively say this is the ASCII code, now we are coming to a conclusion, yes, the hit key is A, or hit key is caps lock, or hit key is control, like this. So, these are the fixed things and we have the ASCII values for this. Suppose I want to press C, so for C we have a specific ASCII code, but when we are talking about the bit oriented devices, specific bit has a significance here. So, this is all about the protocols of serial communication, that what is there in the bit oriented and byte oriented, or say the character oriented protocol. Again, there is a question of 5 marks in university exam, that what is the difference between byte oriented and bit oriented, or bit oriented and character oriented protocol in serial communication. Let us have a look to the another important category, which is very important in this last unit, which is interface. So, what is the significance of interface? Why we are talking about this? So, again I am giving the same example. If there is a change in the speed, suppose your CPU is working with 2 gigahertz speed, 3 gigahertz speed, are your devices, your peripheral devices are able to map the frequency of the CPU? I do not think this. If your CPU is giving the command to print 10 pages, but your printer is not that much fast to just click on one button and 10 pages are out. No, they are taking time. Suppose one page is taking 1 second, so it will take 10 seconds. But on another hand, in 10 seconds, how many oscillations, how many cycles, clock cycles are there in the CPU? It is in thousands. So, this is the speed. When we are talking about the gigahertz, so 1 gigahertz cycles are there. So, this is a frequency per second. You can imagine this thing. Can we say, yes, the speed of the data transfer of CPU and the speed of data transfer of your pen drive is same? No. So, here we need some interface. So, what is the role of interface? To map the speed. Another one, the format. When we talk about the specific format, so this is again different in case of various devices. So, we have some characteristics for which we have these interface, and the standards are maintained. Like we are talking about the functional characteristics, as I said, code conversion means all the devices are not working with the same code. You can't give the ASCII code to the mouse. Mouse has their own coordinates. On behalf of that, it is moving on the screen. The cursor is moving on the screen. Keyboard is working on the ASCII values. Similarly, your hard drives are working on the another way, and your pen drive is working on the another value. So, these are some functional and the physical characteristics. As we know, we have a hard drive, and it is like a electromagnetic hard drive which is moving with the particular frequency. We can't say this is a frequency which is mapped with the CPU. No, this is not possible here. So, in this case, we need a proper standards for the interface. And the another one is the operational. As per the instructions coming, we can't say everywhere each and every device working on the same operational frequency. So, these are some standards which need to be worked on when we are talking about the standards. Like we have the speed, we have the formats, we have the operational characteristics. Let us have a look to the need of these interface. So, as I said, we need to map the frequency. So, here we need to convert it. We need to have some specific idea about the buffer. Suppose you are giving 10 commands and your interface is there to map this frequency and hold on this CPU. Yes, already I have this much data to execute. So, first I am maintaining this part. So, here you can see this, it is mentioned that the different peripherals are of various types, like electromechanical things, electromagnetical devices are there. So, here the speed is not mapped. So, this is the one word where we need the conversion of the signals. Another one, as I said, the data rate. So, data rate is not same. We have seen the memory hierarchy where each and every memory has its own power of transmitting the data, and there is a difference, a huge difference between the access time of the data. So, in this case, to map up the things, we need some interface, and these interfaces are very beneficial in this case. So, yes, the same thing is mentioned here, that we need some specific word formats. It is not like that the operational or opcode on the operand which is making a complete word, we are not same for all the devices. So, we need to decode this thing and convert it with the help of interfaces, and interfaces are like a firewall of a system. Means if I am sending some request to a device, so first it is hitting to the interface, and interface is now converting it in the format which is required by the device. Now, when we talk about some standard interfaces which are required here, so in your syllabus we have the three things. One is the PCI, and another one is the USB. We all are aware about the USB, and another one is the UART. Let's have a look to all three interfaces which are required here. Might be you will see a question in the university exam about these interfaces. This PCI is one which is integrated on the motherboard of your system. It is a hardware and it takes the data. So, this is basically known as a peripheral component interconnect bus, which takes the data and hand over it to the particular device. So, in this case the CPU which is sending the data first coming to the PCI and it is taking the data. So, we have some slots in the motherboard for this. Another one is a very popular one. I hope you all have heard about this, the USB. In our laptops, in our systems, we have our USB ports where we are adding our devices. Either we have a keyboard, mouse. Now, all these peripheral devices have the USB feature, USB connectivity here. So, this is also known as the universal serial bus, where you can send the data, receive the data in an easy manner. So, this is the most common interface nowadays. So, this is a popular one. Next one is about to obsolete and rarely used, which is the asynchronous mode thing, which is also known as a universal asynchronous receiver transmitter. Means this was used in few applications, and right now most of the systems are don't having this UART, but in your syllabus this is one part, it is also mentioned in the book. So, I have covering this part, that this is generally used for the asynchronous mode medium for transferring the data and the communication among the devices. So, this is a UART. This is also known as UART interface. So, this is one good one which is taking the data from the least significant bit, means from the left side, and one by one taking the data from to the most significant bit. So, this is the speciality of this interface, that how the data is coming here and used by the devices. So, this is all about the devices. As I said, this is the last topic of the syllabus. So, let us have a look to the summary, and in this 5th unit all the topics are covered. So, I am just giving one overview about this, because this is more or less a conceptual and theoretical unit, where we have the starting from the interfaces, that we are talking about the peripheral, and we have the IO interface port description, then the interrupts, how the mode of transfer are there. So, this is a necessary question when we talk about the mode of transfer, like this programmed IO, interrupt initiated, and the direct memory access. So, this DMA, now the DMA controller, how the CPU and IOP works together. So, this is again one question which is a conceptual part, and you must be aware about the flow of control in this case, and the today's class which is about the serial communication. So, this part is already covered about this asynchronous and synchronous communication is there. So, it is mentioned here, which was already discussed in the previous lectures, and today in last 5 minutes I discussed about the standard communication interfaces which we have, like a PCI, USB, and the UART. Now, if I give one concluding remark about the syllabus, so we have some numerical problems in this, and for the university purpose I want to focus on specific topics which are relevant to the numerical part. Especially in university exam there is a variation in the numerical part. They on the least side we can say 20%, on the higher side we can say the 50% part will be covered with the numerical in the exams, and this conceptual part. So, let us have a look to this part, so that you can't skip this part. So, that is why I have added this point in this slide in this. So, this is why this is a unit wise description of all the numerical part, that in first unit we basically discuss about the processor and the introduction about the computer organization and architecture. So, here the numericals on the general register organization, stack organization, and the addressing modes. You will see in last 5 years every year there is a question from this part, and the weightage is good in comparison to the other topics. So, just go through these topics in the theory, and for sure work on the numerical part. There are other questions on the exercise on the same book, Morris Meno. So, you can refer those exercise problems on this, and you will see the numericals in the university exam related to this unit number 1. Unit number 2 is basically about the mathematical computation, which is done here with the help of ALU. And ALU, how the ALU is dealing with the things, how the binary representation is there. So the addition, subtraction, multiplication, division. You have seen all the flow charts, all the numericals on this. We have the representation systems, means signed magnitude numbers, 1's complement, 2's complement here. And we have the 3 categories here in the multiplication: array multiplier, simple binary multiplication, and Booth multiplication. So just have a look to all these topics and the flow chart. Third unit about the control unit, where you have seen the differences about RISC and microprogrammed and hardwired, but the important part is about the control word if I talk about the numerical part. Then the fourth unit is basically about the memory, which is also carrying the same weightage as the first unit numerical parts, like the mapping of the memory. If we have multiple memory units, how we are combining it and making a complete address map table for this, and how the virtual memory works, means the paging segmentation part, page replacement policies. Yes, these are the important ones. And fifth unit is more or less a conceptual part, as I said in the previous slide. So this is all about the course coverage. And as this is a last class, so hope you enjoyed the course, and all the topics are carrying all the numericals and the examples. So this is all about the computer organization and architecture. Thank you.